So we're going to wrap up application problems today. We're going to start reviewing tomorrow. We'll continue reviewing on Friday. Then Tuesday is your test. And all things pink are due on Tuesday. Okay? All things pink due on the Tuesday. So, before we get going, I would like to, since everybody has their formative now, and very few people got number 3 correct on it, okay? I would like to do number 3 right now. Okay? Oh yeah, don't have a magnet that you want. What happened to the other one that we had? We used to have 2.
In this one?
Oh, that one. Okay. All right. Like, do we break a third one already? I mean,
There's a wheel there.
See, the nice thing about this one though is because it's 2-sided. So now I set the big side as the eraser.
You can do that.
And so now when I go through,
Oh, I didn't know you could do that.
oh yeah,
That's pretty neat.
oh yeah. So I don't have to keep flipping back and forth.
I like that.
Oh yeah, oh yeah. All right, here we go. I got angle B is 40 degrees. I got side A is 7, and I got side B is 5. What's going to be helpful for us right off the start? What's going to be helpful for us right from the jump? What? What's going to be helpful for us? We're going to draw a triangle. We should always draw a triangle, yes. But I'm shocked that nobody jumped on that one right from the start. Where do you want angle B to be? Bottom left corner? Love it. So if this is angle B, then this is 40 degrees. If that's angle B, where is side B?
The opposite side.
Opposite side of that. Which side do you want to be side A? Left or bottom? Left or bottom?
Does it matter?
It doesn't. Which side do you want? Which side do you want to be side A?
The left side.
The left side. Okay. Because then it's set up like we learned it, which makes this then be angle A. And I don't really care what letter you call that one. You could have called it any letter. The majority of ones that I saw called it C. Okay. Obtuse or acute angle. Well, first off, I know we can't do it when I'm 2 sides. Let's see, we have a triangle, but clearly we have a triangle. Obtuse or acute angle. One that's given, the only angle that we have. It's an acute angle, okay? All right. Opposite versus adjacent. Which one's longer? The adjacent's longer, right? So what does that mean? Acute angle, opposite is bigger than the adjacent. We got to check the height. Okay? Which means we got to check the height. So if I'm going to check H, then my height is going to be the adjacent side times the sine of the given angle, because that's what SOHCAHTOA tells us. Okay? So that's going to be 7 sines of 40 degrees. Somebody with a calculator, give me, what do you got? 4.5. 4.5-ish? Okay? All right, so that's 4.5. that means that my height is smaller than my opposite side, which requires me to find how many triangles? 2 triangles. Okay. So all of that needed to be done before we could even go and now try and solve the triangle. Okay? So now let's get into it. Now let's go triangle number 1. So if I'm going to solve for triangle number 1, then that's going to give me the sine of 40 degrees over 5 is going to be the sine of angle A over 7. Does everybody agree with that? Yes, ma'am.
Oh, how do you know which angle is the opposite and which is like the adjacent, or which side?
Based off of the triangle that we drew. So capital letters are the angles, lowercase of the same letter are the sides,
Yeah.
and they have to be opposite one another.
So it's all based on the angle you give.
Yes. Okay. Solving this, then that would be 5 sines of A equals 7 sines of 40 degrees. So then the sine of A is 7 sines of 40 degrees divided by 5. So angle A, then A sub 1 this is because we got 2 triangles. Angle A sub 1 then is going to be the inverse sine of that. Oklahoma. I wanted to say it was somewhere in the 75 range. 64? 64.1. Yes, ma'am.
We're solving like English or whatever. Are we for the first triangle? We just solve it like normal.
Correct. Okay. So if that's one of them. Then angle C sub 1 is going to be 180 degrees minus 40 degrees minus 64.1 degrees. 140, 80, 76, 75.9. Yes? Yeah? Yeah? Yeah. Then we can go back to the sine of 40 degrees over 5 is equal to the sine now of 75.9 degrees over side C sub 1. Side C sub 1 then is going to be 5 sines of 75.9 degrees divided by the sine of 40 degrees. Side C sub 1, 7.5-ish. Yes? Then we go to triangle number 2. So angle A sub 2 is going to be 180 degrees minus angle A sub 1, which is going to be 180 degrees minus 64.1. 180 minus 60 is 120, minus 4 is 116, minus 1 is 115.9. Angle C sub 2 is going to be 180 degrees minus 40 degrees minus 115.9 degrees. 180 minus 40 is 140. 140 minus 100 is 40. 40 minus 10 is 30. 30 minus 5 is 25. 25 minus 0.9 is 24.1. Not gonna write any of this down, Joe? Not gonna write any of this down? Because you don't need this at all, right? No. Okay. Because I saw your formula. You're not writing any of this down. Not gonna help you at all in the future? A little late for that now, isn't it? Well, I'm already 5/6 of the way done with the problem. And you still haven't figured out that you should write this stuff down. And instead, you're going to do some other class's work. Because that's what's on top right now, right? Well, you get your math out. Oh, wait, you don't even have that out. Side C sub 2 is going to be 5 times the sine of 24.1 degrees divided by the sine of 40 degrees. So side C sub 2 then would be 3.2-ish. What do you got?
Oh, I just have a question.
Okay, go ahead.
We were wondering for like when you're trying to find angle A and angle A sub 2 and angle C sub 2.
Yep.
How do you know which one is 180 minus the first one?
Whatever the first angle is that you found.
Okay.
So if we would have found angle C first, way back over here,
Mm-hmm.
then we would have found angle C sub 2 first over here by finding the supplement of it.
Okay. And then for the second one, you just do.
That's just 180 minus the other two angles. Yep, triangle sum.
Oh.
So over here, Abby, we found angle A sub 1 first. Okay, right? So over here, I got to find angle A sub 2 first again.
And the first one, like the first one,
In the second triangle, yes.
and then.
And then this one is just the three angles of my new triangle have to add up to be 180 degrees. Given angles locked in at 40. No, you can't do it. You can't do it by going angle C sub 1 or 180 minus C sub 1 and then going. Correct. Same order in both triangles. Okay. All right. All right. So what I would like you to do now is I would like you to put those formatives away. Okay. I don't want to see anything green out anymore. I don't want to see anything pink out right now either. I want to see your notes out now because now we're going to take some notes. Okay? You might you might need your purple sheet out. Oh, nope, don't need your purple sheet out. Okay? Straight up triangles today. Okay? So here's your two warm-up problems. Get going on those two. Solve me triangles based off of those two different classifications. Oh, that's right. I got a parallelogram drawer. Do we?
We do. There's a shape. There it is. Yep. Nice one.
Parallelogram drawer. Love the parallelogram drawer. So the parallelogram has lengths of 3 and 4. We You define that. Let's call it x. So if it's got an angle of 70, that's going to be on the short one. So this one right here is 70. If that one's 70, how much is this one right here? It's 110. Okay? So now it just becomes a simple law of cosines problem where x squared equals 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 110 degrees. Calculator's got to fire up. And use my cheaters. 4 squared minus 2 times 3 times 4 times the cosine of 110. I get that.
That's what I got.
Because you got 5.76, we'll go 5.76.
That's what I got.
Because you got it, I was going to go 5.8 for half a heartbeat. And then that's what I got, 5.76. Okay. Solve the triangle, so we should probably draw ourselves a triangle. What we got to do first? Find the height. We got to check the height first. Height, again, is going to be the adjacent side times the sine of the angle. So that's going to be 8 sines of 62 degrees. 8 sines 62. It'd be 7.06358. How many triangles? None triangles. Okay. Questions, comments, concerns, clarifications? What's up? Love it. I'm there. Because this is x squared.
Yeah, but why
Good thing. Good thing's always a good person. Let's do it. 2 lighthouses, A and B, are known to be exactly 20 miles apart on a north-south line. Okay? North-south is up and down, yay? Okay? This is kind of a preview of things to come, because next unit is all about navigation. And so we're going to take the unit circle and turn it on its head, because we're going to zero is not going to be straight up to the right anymore. 0 is going to be straight up and down. We're not going to go counterclockwise. We're going to go clockwise. All kinds of different things. Just when you think you have all the answers, we go and we change everything on you. Okay? Because we're mean. Okay? So, then, 2 lighthouses, A and B, are known to be exactly 20 miles apart. So we should probably put A and B on there, but we don't know quite where they land yet. So let's just put here and here and we know that that length is 20. Okay? A ship's captain at point S measures angle ASB to be 33 degrees. So if I put point S out here, then angle ASB would be 33 degrees. A radio operator at B measures angle ABS to be 52 degrees. Find the distance from the ship to each lighthouse. So we need to find this distance X. Actually, to be honest with you, we could call that distance right there B. And we could call this distance down here. Do I have enough information as is to complete this process? All right, talk to me. Sine of 33 degrees over 20 equals equals the sine of what over A? 95? We all in agreement with 95? All right. What do you want? 2? 1? 2? You tell me. 2? You set the decimal limit at 2. Agreed? Yep. Questions, comments, concerns, clarifications? Try that one. So we need to find this side. So then that's going to be 7 907,644. And so then I get that the distance that we're looking for is 841.2 feet apart. Because D said we're going to 1 decimal. Really, I got 841.216. What? Did it ask for it? I could be mean and I could say, I could. I'm glad that you sit in the back if you can't read the board. What's up? Never.
I knew that, but
the reason that one of the reasons that I love the drafting calculators is because you can store up to 26 different things in it.
I mean, like, I could do it with this thing, but
Right, but you can't, like up here, like I can store as many as I want, and so I can never have to round. Never ever round until the end. Yeah, never ever.